Chapter 6 Sample Problem 8. The belt crank fits over 100 mm diameter shaft which is fixed and cannot rotate. The horizontal force T, as shown in the picture, is applied to maintain equilibrium of the crank under the action of the vertical force P equals to 100. Determine the maximum and the minimum values which T may be have without causing the crank to rotate in either direction. The friction between the journal bearing and the crank is 2/10. At first we are going to provide a free body diagrams for the crank shown here. Excuse me. At this point we have considered this circle as an inner crank. Let me show it a bigger size and the, for example, force T here and force here. Concurrent point of the two forces. Forces are the friction circle here, RF, the normal from the friction force, the resultant of forces on the bearing is tangent to the friction circle and normal to the, and have a angle to the normal of two normal direction to the this phi, and should be past the point C. Beta is here, phi is tangent inverse mu. Beta is RF is R, it is RF. The friction circle radius R sinus phi. Beta is RF on OC tangent inverse R. Let me check again. This is normal. Sinus inverse. Sinus inverse RF on OC, and also theta or this is theta, the direction, the OC direction to the circle, theta tangent inverse this distance Phi can be calculated and is RF, which is relation. Beta can be calculated. And theta with this calculation we can provide the free body diagrams. With this free body diagram, triangular law, at first we sketch P, and at the end of the PT, in which direction the R one direction satisfied, we continue this R1. So this angle is angle between horizontal theta minus beta equals to this angle theta minus beta R1 and P T1. With these free body diagrams, it is assumed that the direction of frictions are in the opposite of the motion, so it is assumed that the motion is R1. Let me exaggerate the contact surface N and counterclockwise is in this direction, so force if we want to exaggerate it is direction to the opposite to the direction is opposite to the motion, so the force is in the upper circle of friction. With these relations we can write the free body diagram as this picture and triangular law. T1 can be calculated from this relation. Sigma fx equals to 0 R1 cosinus T1 to R1 cosinus alpha minus beta sigma fx fy R1 sinus alpha minus beta equals to P. So R1 equals to P on sinus alpha minus beta. Substitution to the previous relation, we have this T1 equals to P cotangent alpha minus beta. T1 100 cotangent alpha calculated before, phi theta, excuse me, this theta calculated, beta T1 for the clockwise motion, we have this relation. The equilibrium in triangular shape T2 R2 and R2 sinus P cotangent alpha plus beta alpha theta T2 Newton for the clockwise motion.